Hi, I am flying from Gloucestershire Airport to Shobden in X-Plane and I am lost. I don't know where I am. I've looked around, I can't really see the airport anywhere, and now I don't really know what to do. So I wanted to create a video to tell you how I've ended up in this position, how you might end up in this position, and more importantly, what you can do about it. So let's go back a few hours and go back to our flight planning stage. Now I've decided that I wish to fly from Gloucestershire to an airport called Shobden. Now Shobden is about 35 miles from Gloucestershire Airport, which is my local general aviation airport. And I've chosen Shobden because it's relatively small, it's quite cheap to land there, it's not very far away. So when I'm learning to fly, I don't really want to be flying hundreds of miles when I could be making lots of takeoffs and lots of landings. So I fly 35 miles to Shobden. It doesn't cross any controlled traffic areas, so it's a fairly easy flight. And of course, back in the olden days, before you had any kind of radio navigation aids, you really just had paperwork. So one of the things that you would do, you possibly would have a chart or a drawing to show you roughly the layout of the aerodrome. And you might think it's kind of not that important. But one of the things that is really important is getting an idea of what this airport actually looks like. When I actually find it, if I've never flown there before, what is going to look like when I'm up in the air. Now, one of the reasons that's important, it happens fairly regularly in the UK at least, and I'm sure elsewhere, where pilots get lost and they can end up landing at the wrong runway, at the wrong airport. So let's go back and have a look at Gloucestershire Airport, where I'm taking off from. And if I look at the aerodrome chart here, now if you have a look at Gloucestershire Airport and you have a look at Shobden Airport, hopefully you can see that they really are quite different. So how was it that somebody accidentally landed here when they thought that they were landing here? And the simple answer is they hadn't checked this chart. They hadn't remembered roughly what their destination looked like. So when they approached here, they should have spotted that it didn't look anything like this and realized what they'd done. Instead, they started an approach to land and narrowly avoided a collision with another aircraft that was taking off. So anyway, go back to the planning. I've got my chart. I kind of look here, nothing particularly special. We have an asphalt runway in the middle. It's long enough because I'm only flying a Cessna. That's all grand. And the other thing that I'll need to look at is the information for this airport. Now, of course, nowadays, most of this is on the internet. Back in the day, you had to have a book, and that book would have to get updated, obviously, quite regularly as things changed, even as coordinates changed due to, or headings changed due to the movement of magnetic north. But there are a couple of things that are interesting to note. The first is this is a VFR, Visual Flight Rules Only aerodrome. And that means that I'm not going to come across any civil airliners because this doesn't permit any instrument flight rules flights. So that probably tells me that it's going to be quite a quiet airport. It's going to be smaller planes, maybe lots of them, maybe not that many, but they're all smaller. They're all going to be flying the pattern. So all going to be kind of good. Now, another thing that is significant is this line here. It doesn't matter so much in the simulator, but use of the aerodrome is strictly prior permission required by telephone. In other words, you can't just turn up and say, can I land? Because the person in the tower might be in the toilet because he didn't know that you were arriving, and then you might have to attempt a landing without any guidance from the ground. And of course, I don't need to tell you that that could be potentially very dangerous. So we call up by telephone. We tell them roughly when we're arriving. Obviously, they can give us any updates at the same time on if anything's happening near the airport, whether the hang gliders are in operation, whether people are parachuting nearby, etc., etc. So that's kind of really important. Most of the rest of this you can look through yourselves. At the moment, I'm not too bothered about the remainder. But in terms of actually plotting a course, there are two ways in the real world that you can navigate without using radio navigation. The first of which is quite simply to look out the window and to navigate using visual reference points. So if we have a quick look at this map, this is a map where I've actually plotted the course between Gloucestershire Airport down here and Shobden up here. My map doesn't have that line on it. I just drew that on the computer. But if you look here, you will see various artifacts on the map pointed out. So that's saying here at Ross, there's a bit of a peak in the hill there. You've got a Strensham helipad. You have various high-level either zones that you're not allowed to go into because they're restricted in some way. And occasionally, although I can't see any on here on this part of the map, you have a visual reference point. So it might be something like a large roundabout on the motorway. It could be, a service station. It could be a bridge. And quite simply, using your eyes, you could navigate from Gloucestershire. You could try and head in fairly small steps between things that you should be able to find. So from Gloucestershire, you could go west until you got to Ross on Wye. You could then go up towards Hereford. Hereford's quite large, so you should find that quite easily. And then you fly slightly northwest. And because this leg is quite short, the chance of you kind of going wrong is obviously reduced if you take a bearing on smaller distances. But what I've done here instead is I've said, well, as you might have noticed in simulators like X-Plane, the scenery is hardly photorealistic in most places. So even if you fly over Hereford, you can't see Hereford. You can just see a funny little mark on the map. So you can't really use that method very easily in most flight simulators unless you get kind of the additional scenery packs, and then they only cover certain areas. So then your second method, if you don't have any radio navigation aids to use, is something called dead reckoning. And dead reckoning is quite simply flying a heading for a period of time to try and estimate where you're arriving at. So I measured this with my protractor, and that worked out at 310 degrees. So theoretically, if I flew 310 degrees, I worked out that at an average ground speed of about 125, I think it was, it would take me around about 18 minutes. So if I fly at 310 at 125 knots ground speed for 18 minutes, I would arrive roughly at Shobden. And because I'm flying visual flight rules, I don't have to arrive anywhere in particular. As long as I get close to the airport, get the airport in sight, at which point I can radio the tower, tell them of my approach, and then carry on. So, of course, that's all grand. The problem with dead reckoning, as you might imagine, is it's incredibly fraught with risk. Now, in my case, what I've done is I have deliberately flown off course. So whereas I should have been flying at a heading of 310, I've been flying between 315 and 320. Now, I did actually try the other day flying at 310 and I got fairly close to the airport. But of course, I'm flying here in good visibility. I don't have much of a side wind, don't have much of a headwind. So I can kind of estimate things fairly accurately. But of course, in the real world, I could be flying in darkness, although I wouldn't be flying visual flight rules, obviously, if I was in the darkness. But I could be flying in bad weather, even though I shouldn't take off in bad weather. Maybe some clouds just suddenly come down, so maybe I can't see very far. Maybe I've got a side wind, it's been hard correcting it. Maybe I've been concentrating too much on other things and not keeping my speed steady. So, of course, there are a whole load of ways in which I could go wrong. And just to kind of give you a clue as to where I've gone, if you look out the corner of the plane here somewhere, although I think it's actually behind that part of the wing, if I'm correct, Shobden Airport is just over here. So actually, even though... it's over here. You can see it in the distance there. So even though I'm kind of close enough, in real life, I would probably still be able to see this airport, even though I've gone quite wrong. But of course, that's not necessarily the case. If I've done my maths incorrectly, if I've measured off of the map incorrectly, and I've flown a heading maybe 20 degrees out for 5 miles longer or shorter, then I can't even see the airport. And in an even worse case, if I've got it wrong, but I can see an airport, I might make the assumption that it is my destination, even if I've ended up at the wrong airport. So All of those things make this kind of a really risky proposition. And so that's why I want to do a couple of videos really to introduce you to radio navigation. And the first of which I'll cover in this video is the simplest of all, and it's called a non-directional beacon. Now, a non-directional beacon is a fairly simple beast. As you can see here, it's usually a fairly basic antenna. It's relatively cheap compared to some of the other nav aids that we can use. But at the same time, it's very easy to use, and in many cases in the UK, possibly in all cases, I haven't found any independent NDBs. They are almost always located at the smaller aerodromes. So larger airports tend to have more sophisticated navigation, but in this example here, you can see Haverfordwest, which is in West Wales, and you can see here that it has an NDB. Now, because this NDB exists inside the airport control area, which is the dotted line, it's not printed on the map with the normal symbol, which is all of these dots. If you printed all those dots in there, it would cover everything up. So what you'll find on most of these nav maps is a box with the word NDB in, then an identifier, and that's important, we'll see in a second, and then the frequency that that NDB is transmitting on. Now, literally, that transmitter is sitting there beaming out a signal, but the clever part is if you have an automatic direction finder in your plane, which most planes, including very basic ones, will have, then you can get a needle to point towards that beacon and have a very, very simple way of navigating to it. So if we look back at this picture, you can see there's an NDB shown at Gloucestershire Airport. The airport we're going to is Shobden, that also has an NDB. Not every airport has one, but in most cases they do. And in some cases it's used as an approach aid when we're doing a standard instrument approach. We'll look at those in a later video. So what I want you to kind of notice is, I want you to also notice here, it shows you the Morse code for HAV in this case. Now, how do we find out the NDB frequency? In X-Plane, in Microsoft FSX, you can generally find it on a map. If you open your map, you can find the NDB on the map. You can click on it. It will tell you the frequency. In X-Plane, you can even press a button to automatically tune it for you if you're feeling a bit lazy and you don't want to fiddle around with the radios. But again, at the planning stage, you're not going to fly towards Shobden and then suddenly go, oh, I wonder what the NDB frequency is. Let's try and get my iPad to work. Clearly, that would be a foolish thing to do. It's all in the planning. These are the kind of details that you get in advance, not just for your primary location, but you have to plan for a secondary. If you got to Shobden and there was a problem, you know, where's the nearest place you can fly to? Maybe you would just return to Gloucestershire in my case. Maybe if you've flown 50 miles or further, you might prefer a closer secondary where you can refuel. So how do we find out the information? Well, we go back to the charts, and again, back in the day, this would have all been in a book. Let's forget Gloucestershire. So it's shown here. If we zoom in, if I can, SH is the identifier. Most of the older NDBs have 2 character identifiers. As more and more NDBs have been installed, they've had to start using 3. But you see the letters SH, you'll also see the Morse code for SH happens to be 3 dots and then 4 dots. And that's important. And then you'll see the frequency of the NDB. Another thing that again is just worth noting in your head is that the NDB is located on the airport, which is usually the case, but it isn't always. Sometimes the NDB might be off the end of the runway. Sometimes it might be, a reasonable distance off of the airport in one direction or another. So they're all things you need to check if you're going to use it, particularly for an instrument approach. But for us, we're just using it for a very simple navigation aid. The other place we can find it is in our list of text data. And of course, nowadays you have electronic flight bags, you have iPad apps, you have GPS units, you have all kinds of stuff that will tell you this information. But the most important thing is that you need to know this before you start flying. You can't assume that you will be able to find it out once you're there. The last thing you need to do is call up the tower in emergency and say, oh, by the way, can you tell me what your NDB frequency is, please? They might not be best impressed with that. And it kind of goes without saying, you can't exactly pull over at the side of the road and ask a passerby which way is it to Shobdon like you can in your car. So because the risks are higher, as you'll be told many times if you do any proper training, it's all about planning. If you plan well, then the flying is relatively easy. If you don't plan well, then you're asking for an accident to happen. So unsurprisingly, we have the same information. It's an NDB, that's the type. We will look at these others in later videos. The identification is SH, frequency is 426. It's in operation 24 hours, which is standard for most NDBs at most airports. There isn't a lot of benefit in switching them off at night, so that's pretty handy. And what that means is you can use that as a waypoint, even if you're not landing at Shobdon. You can use it to fly a route in that general direction. The position of it is not that important to us. So that's the information that we need to know for our NDB. Just in mentioning, I mean, this is a relatively long document, but Shobdon's quite a small airport. There are interesting things to read here. The more you get into flying, the more you get into flight simming, you'll realise that the actual flying part's quite boring on a flight simulator because the scenery, isn't usually detailed enough. You don't see live air traffic in the same way. You don't have all the cool stuff, and you don't get food brought to you by the cabin crew unless you have an understanding partner. So trying to kind of fly more realistically, these kind of things can be quite interesting. So you might have noise abatement procedures, and these are a big deal in the UK. There are lots of these areas where you're not allowed to fly over particular villages or schools. So there are instructions here that you could read if you want to try and kind of make an accurate approach to Shobdon in this example. Various flight procedures, the circuit height, 1,000 foot. QFE means the altitude above the runway, so not 1,000 feet above sea level, but 1,000 feet above the runway. And somewhere in here there'll be a setting for your altimeter. But with that information, I've got enough now to actually tune in my NDB instrument. So let's jump back to X-Plane. Obviously I'm paused at the moment. I'm not going to unpause it just yet. Now I flicked this onto the flight plan page just to give you kind of a visual reference. So if I go back to the non-flight plan page, let's just zoom in a touch if I can get that. So that's Shobdon. The pink line is the line that I should have taken, but because I've flown off course, you can see where I actually am. And I just programmed in, again, SH. Every GPS system is going to know, well, or it should know, all of these nav aids. So SH is globally unique. So I can type in SH, it knows that Shobdon, it knows where it is, and obviously it can give me things like distance and things, all worked out from GPS. But we don't want to use GPS at the minute. We want to learn the basics, and we'll build our way up to GPS and flight plans later. But what I want to point out is that you have, in most of these planes, you have your nav1 instrument, which, depending on the model of plane, in this case it's quite a featured one. It has the glide slope indicator, which means this can be used to tune into an ILS frequency if you're doing what we call an instrument landing system approach. That's coming into an airport. It has a beam that shows you the angle, the best angle to land at. And then using this horizontal bar here, you can tell whether you're above or below the glide slope. You then have this up and down line, which is basically a heading indicator. And we'll see later on when we're tuning into VORs that this can help you know not just whether you're flying towards a VOR, which is a more sophisticated type of beacon, but also whether you're approaching it at the right heading or not. But we're not interested in this one just yet. The second one is similar, but you notice it doesn't have a glide slope. So the only reason you have a second one is occasionally, rather than flying directly to a beacon, you might be trying to find the intersection of two different beacons at the same time. So you might say, well, when I'm pointing, 90 degrees towards one beacon and 0 degrees towards the second beacon, at that point, that's when I want to turn left or right or south or whatever I'm doing. So you can use two lines to kind of triangulate those intersections. And again, we'll look at that a bit later. But the one I'm interested in right now is called the Automatic Direction Finder. And when the Automatic Direction Finder is not in use, the arrow points to the east like that. So but bear that in mind. That doesn't mean that you've got to fly to the east, although obviously sometimes you might need to fly to the east. But we'll see what happens in a second when we turn that on. So normally we would tune in these navigation instruments using, let's just pop this out and drag it in, using the navigation location frequencies here. So you see 110, 117. So that's for, nav1. And then you can set frequencies for nav2 as well. We'll worry about that later. But when you're using the automatic direction finder, you instead have to set the transponder frequencies, the frequency that you want to connect to over here. Now, just as an interesting side note, you can actually tune into any kind of medium wave transmitter. So it has been done before where somebody's got lost and they thought, let's just tune into, Capital Radio or something like that and tune into their frequency, because it works in the same way. It basically listens for what direction that beam is arriving in. So what did we work out? We've worked out that the NDB that we're interested in is at the frequency 426 kilohertz. Now, the way that most of these systems work in the plane is we adjust the standby frequency. So we don't change the active frequency, we change the standby one, and then when we're ready, we hit the button and it swaps over. Now, what's going to happen when I unpause is that automatic direction finder is going to come alive, because I'm right in Shobdon, and it will be able to find it. So let's just center that and pop that down again. So let's just unpause briefly. Just straighten up a little bit. So we can see here that just by enabling that one really simple navigation aid, this is telling me what direction Shobdon Airport is in. Now, it doesn't tell me how far Shobdon Airport is. There are ways to actually calculate that using the NDB. They're pretty extreme. I might talk about them in a later flight, but it basically involves flying a particular pattern and then calculating some numbers to actually work out how far away you are. There are easier ways to do it in most cases, and obviously with a GPS unit, an even easier way. But even using dead reckoning, I obviously know that I'm in the rough area of the airport. So the fact that this is telling me that it's west means that I bet if I turn and start pointing to the west, in fact, let's just do that, then it's hopefully not going to be very long until I can spot Shobdon Airport. So I'm just going to try and bank. I'm not really used to my joystick, so when you bank you have to have a little bit of back pressure depending on how tight you're banking, because the nose dips a bit. Now notice that the compass on the NDB, on the automatic direction finder, doesn't move. So the arrow always points relative to the plane. Now, if we can just see in front, let me just pause. You can see now that the arrow is basically pointing to Shobdon Airport, which is just in front of me there. So obviously while that's pointing to the airport, I can follow that. Even if I really can't see it, I guess I'd have to be blind or desperate or whatever. If I carried on flying, obviously once I flew over the airport, that arrow would turn around 180 degrees and point behind me. So it doesn't really take much working out to find out where I am. And of course, the good thing about flying the pattern in a light aircraft is that I'm not trying to kind of hit an approach intersection and then do a straight in landing. Most of the time, I need to get to the airport first, then fly, upwind, cross downwind, fly the pattern, and then come round and land. So even if I'm still quite high, I'm still at about 3,000 feet. I'm way too high to fly the pattern. The airport's only 5 miles away. So at this point, obviously, if I got lost, I now need to decide what to do. I can either slow down a lot, try and lose a lot of altitude quite quickly. I could just maybe overfly the airport, descending gradually, and then make another circuit. So all of those things I can work out, but what I wanted to show you was just how easy this is. But there is one other thing. Do you remember we saw the Morse code? And do you remember that the Morse code for Shobdon is ... And how are we going to find that out? We're going to hit our ADF1 button, and if I unpause it, after a while, you'll hear it start beeping. So hopefully you can hear that. Goes every, I think, 10 or 20 seconds. Yeah. Now, why is that important? Let's just pause that. We don't really need it anymore. The NDB can transmit really for quite a long distance. Now, most of the NDBs that you find at an airport are going to be what we call NDBL, L for locator. And because it's a locator beacon rather than what we would traditionally call a waypoint beacon, it means it's only really used for things maybe up to about 30 or 40 miles away. But of course, you can't really control that very well in radio. It's going to kind of go as far as it wants to go. And so there's a good chance that if I tune into, the wrong frequency by accident, I might well pick up an NDB that's roughly in the same direction, maybe 10 degrees to the left or 10 degrees to the right. And of course, that could confuse me, and that could end up sending me off course. So what's really important is when you first tune into that NDB, as soon as you see the needle start to move and it's picked something up, that you use the ADF1 button to make that beep come onto your into your headphones, so that you can work out that you're definitely pointing to the right place. Obviously, in this case, I know that I'm close to Shobdon. Once I've homed in on that, it only takes me a few seconds. I'm going to find the airport and I'm going to carry on. I don't need to do anything else. If this was a waypoint, if you're traveling much longer distances, then you might want to check that. If you've kind of taken your eyes off things for a bit, you might kind of think, oh, am I still pointing to the right place? So obviously you can recheck it. Doesn't take long. It's just Morse code, and that works really well. So that was the first, hopefully, very easy lesson in using radio navigation. So let's just recap what we talked about. An NDB is a non-directional beacon. It sends out its signal in all directions. That's why it's called non-directional. And the symbol would look like this. You won't see this on, I don't think, anywhere on a UK navigation chart that looks like this, because most of the time NDBs are co-located with small aerodromes like this, and because they're inside the circle, that symbol would look really ugly. So instead you get a little box with the letters NDB, just to confirm it is an NDB. It has an identifier, which is 2 or 3 letters. It has a frequency, which is usually quite a high number. When we look at VORs and distance measuring equipment like this, you'll see they're on the kind of lower frequency range. And it will have a Morse code signal which enables you to verify that the NDB that you're looking for is the right one. And then in terms of tuning it in, just to recap, this knob will set the standby frequency, or we can use in X-Plane anyway, you can use the map to click on the NDB, click the button to tune your ADF1, and it will tune that frequency automatically for you. Otherwise, program this in, flick the switch to swap them, and then as soon as the aircraft antenna picks up that frequency, if it picks it up, if you've got it all right, then that needle will come alive and point you in the direction you need to go. If you need to hear the Morse code signal, you hit that button there, ADF1, which is the left-hand side. You can actually listen into ADF2. You won't see it on the needle, but if you're trying to find one, you can set up the standby, flick on ADF2 just to verify that you have tuned in correctly, and then turn it off again, so you know that when you then flick to the next NDB that you're definitely going in the right direction. And then all you have to do is turn the plane to follow that needle, or in some cases you might be flying again an instrument approach that says, you know, fly at 30 degrees from it, or something like that, but we'll worry about that in instrument landings later on. So hopefully that's enough information to get you going with the basics. Open up your flight sim, open up the map, find some NDBs, find some little airports that have an NDB there, and practice doing some short flights, flying towards the beacon, working out how to do all of the many things you have to do while you're trying to keep your vertical speed steady and your altitude steady and your speed under control at the same time you're trying to fly a heading and all the rest of it. You know, a lot of that does take getting used to, and in fact some of it is harder to do in a flight sim than it is in a real plane, because in a real plane you can turn your head and move your hands a lot more easily than you can, you know, flick a little hat on a joystick and, you know, try and find what you're looking for. But have fun with that. In the next video, we will look at VORs and distance measuring equipment. We'll also briefly mention TACANs and VORTACs, but they're less important for kind of civilian flying. So hopefully you enjoyed this. Any questions or comments, put them underneath as usual. And I will see you in the next